Okay. Instead to record this, so if you look at this one, we are talking about late binding. If music player is the parent of CD player, are the following assignments valid? This is valid because, as I said, you always ask yourself, is CD player a music player? If that's the case, yes, it's okay. You can assign a CD player to a music player, right? Because a CD player is a. If this music player class has a play method, okay, play. And if CD player also has a play method, okay, both have play methods. What's that mechanism called? Let me ask you this question first. If both of them have the play method, what is that mechanism called? Okay, that's called method overriding, right? The child class version overrides the parent class's version. So they have to have the same name, same signature, but the child class provides a more specific version tailored to itself. So we call that overriding, right? So suppose they both have a play method at compile time, okay, at compile time. Which class do you think, if you do this, if I do this, it's difficult to write here. So I will say, let me do it here. Player dot play. If I have this method call, okay, I'm going to ask you, at compile time, where does the system look for that play method to make sure it can compile? At compile time, where does the Java machine look for the play method at compile time? Everybody?
At compile time, it'll go to music player and see if the method is in there.
Yes. At runtime, which method will it run?
At runtime, it'll run the method from CD player.
Exactly. That's excellent, Jesus. That's absolutely correct. Okay. If you, well, let me write that again. Okay. So if you have this, this statement, suppose they both have the play method, right? If you have this statement, at compile time, it will look for the play method in music player. At runtime, it will use the body of the CD player class. The reason is at compile time, it looks at the reference type. At runtime, it goes to the actual object type. This is the object type. This is the reference type. Okay, so that's called late binding, right? That means actually which body is bound to this method, it's decided not at compile time, but at runtime. That's why we call it late binding. Okay, and this one, am I recording? Yes. And this one, this will not be correct. This is not correct because you ask yourself, is a music player a CD player? No, not all the time, right? Because this is a more general version. This is a more specific version. So we cannot say that's true. That's why this statement is not right. It will not compile. You'll have to use a cast, and we discussed that last time. Okay. So now let's talk about, I believe this is where we stopped. This is where we start the new class, polymorphism via inheritance. Okay, so we talked about late binding. That is the precursor of this. And so that's the mechanism actually of polymorphism via inheritance and interface. Okay, given the following class hierarchy, let's look at the example. Firm, okay, let me ask you, looking at this UML diagram, this is the UML diagram, right? Looking at it, What do you see? What's the relationship?
Staff member looks like it's
Staff member is the parent class, and then
and then off of it goes volunteer and employee as child,
of staff member. Okay.
and then hourly and executive are children of employee.
Hourly and executive are children of employee. Yes, and volunteer is the last branch, last class in this branch, right? So yes, that's correct. Okay, super parent. Who's the parent of staff member? Everybody.
Object.
Object. Yes, object is the parent of staff member, and employee is the parent of these two, but employee is also the child of these two. So executive, if staff member has some methods, can executive use the methods in staff member? Yes or no?
Yes.
Yes, yes. It inherits all methods, right? From the superclass. No matter how many generations you go back, they inherit. Okay, let's look at these classes. And you know, after class, you can read these carefully, and I'm going to explain them, but you can also read them. So let's look at this. This is the class, right? This is the firm class. So if you look at this, let's look at which class? The firm. Okay, let's look at the firm class. That is the first. This is the driver, really, right? The driver. So in this driver, we only have two statements. One is instantiate a staff variable, okay? And then just call the method for that in the staff class, which is payday. And that's it. And when you run, did I run? Yes, when you run, this is the output. You know, how do you get so much output from these two simple statements, right? So all the devil is in the details. All the code is behind the scene. That's what object-oriented programming is about. That means it encapsulates. It wraps things up so that you don't see them. On the surface, you just see a very abstract, you just see the abstract level. You look at these are very abstract, not detailed. And so this makes the reader, this makes it much easier to understand, right? So you look at it, oh, you see, oh, you create a staff object reference variable, and then you call the method payday, and then we will see who gets what. So it's very easy to understand. That's what object programming is, object-oriented programming is. It makes things easier to understand. And all the detailed stuff that you do not need to see is behind the scene. It's, once again, to use that analogy, it's like you're driving a car. Do you need to know the detailed working mechanism inside the car? No, you just need to, oh, give me a beautiful car. I can drive it. That's it, right? The methods are drive, brake, back. What is that? Reverse. You know, those are the methods. And you, as long as you know, oh, I can do this, I can do this, I can do this. That's it. You don't need to know how the mechanism is, what the mechanism is, and all the detailed actions are behind the scene. You don't see them as a user. And that's what really object-oriented programming and design is. Okay, you look at this driver, it's very abstract, high level, right? Like English language. But behind the scene, let's look at staff, okay? If you look at staff, if you look at it, this is the class name. The instance variable for staff is staff member, okay? And staff member is just not, it's not just one instance, it's an array, right? It's an array. So this means staff is, I will let you fill in the blank. Staff Okay, just tell me the relationship between staff and staff member. What's the relationship? You remember we discussed depends, uses, aggregation, composition, inheritance, right? So it's has a, uses, what kind of relationship is this? Everybody, what's the relationship?
Inheritance.
Inheritance. Okay, staff protected. What's the two standing out, standout features of properties of protected, everybody?
It can be seen by anybody that's in the package or any class that's in the package.
Yes, and
the children.
Yes, exactly. Yes. So protected means that any class in the same package can directly reference it by name. Any child classes can directly reference these variables by name. That's protected. Okay. So this is the constructor, initialize all instance variables. That's what this is doing. And toString, right? Just return the values of all the instance variables, and in this case, format it using the neoline character to format. And then there is this abstract method called pay, right? It returns a double. It's abstract because this is abstract, an abstract method. Your class must be declared as abstract. Okay, so public abstract double pay, and you have no body because it's abstract. Okay, that means any class that derives from staff member must implement the pay method. If you do not implement the pay method, you must declare yourself as abstract, right? Okay, that's the staff member. Now let's look at executive. Okay, executive, besides name, what is it? Name and address and phone. Besides those, it also has one more extra instance variable, private double bonus. You look at this, how unfair it is. Executive gets bonus. Okay, so for executive, it accepts all the ones for its parent. That's for, oh, I'm looking at executive. I should look at employee. Let's look at employee first. Okay, so employee, right? It's employee extends staff member. So besides all the name and everything, it has another two instance variables, social security number and pay rate. And here it accepts all these to instantiate the parent part. You remember for the child constructor, you always instantiate the parent part first. You always construct the parent first. So this is how you construct the parent part, right? And then add to it, that's the child part. Okay. Using the parameter value and toString. And toString, this will give you the parent part. This is calling the parents toString. And then you simply add to it, add your own version and return that result. Now let's look at this public double pay. Remember, this is the abstract method in the staff member class. And this pay, just return the pay rate. For employee, there is no bonus. There is no hourly rate. It's just your pay rate. So yearly pay rate, right? Salary. So you just return that, whatever that is. That's employee. Let's look at executive then. Executive extends employee. So executive not only must have everything from being a staff member, it also has to have everything from being an employee, right? Those are the two things for an employee. So which constructor is it calling with the super method? everybody, with this super keyword. Which method is it calling? Whose method is it calling? Which one? That super is referencing whom?
The employee.
Employee, yes, employee. And if you go back to employee, you see that it accepts all those 5 and construct the staff member and then add on to employee, right? So executive is calling super. This is the employee part, all 5 instance variables, and then initialize bonus to 0. That means if you are an executive, when you create this executive, its bonus is 0. If you want to give him bonus or her bonus, you have to call this method, which is award bonus. Give me the number, I will initialize bonus to whatever you want to give, right? That's award bonus. And then this is implementing the abstract method pay, okay? So super pay, this is calling the pay method of the employee, right? Super references employee. So if you remember employee, just returns the pay rate. So for this executive, you get the pay rate of being an employee, and you also get the bonus. If it's 0, then it's 0. If you already get called award bonus, then you have bonus there, right? So that's your pay. And then we reset bonus to 0 because award bonus should be a one-time thing. And if you want to give him or her a bonus again, you need to call this method again. That's why we reset bonus to 0. Otherwise, it's always there. Every time you call pay, this year you call pay, you have the bonus there. This month you call pay, it has the bonus. Next time it has the bonus. So that's why you set it to 0. And then you simply return that payment, right? Any questions so far? Okay, let's look at hourly. This also extends employee. And for this one, since it's hourly, you have to know how many hours this employee works. So hours worked, that's the specific instance variable that caters to this specific class. And then when you instantiate this, all these parameters are for the employee class, right? Name, address, phone, social number, rate. These are for the employee class. So you simply use the super keyword to call the employee's constructor. And always the super call is always the very first statement in the constructor. So you construct the parent part first, and then you instantiate hours worked to 0, initialize hours worked to 0, okay? And then add hours, and you simply add to it, right? This is easy to understand. And let's look at the double pay. So payment is the pay rate, which is the hourly rate times hours worked, and then reset hours worked. You know, each month you pay this person. After the hours worked is used, you need to reset it to 0 for next month. That's what this is. And then you return payment. And toString is simply calling the employees toString and add the hours worked to it. That's the toString method. That's hourly. And volunteer. Volunteer has no specific attributes. It's simply the pay method is different. You don't get paid anything. Okay, those are the child classes. And then let's go to staff. Any questions so far, everybody? We explained everything, right? Okay, so if you look at this, we said abstract method is to be overridden, to be implemented by the child class. So if you look at staff, staff is the staff. We will look at that again. If you look at employee, this is the pay method, return the pay rate. But if you look at executive, you need to add the bonus to it, right? And if you look at hourly, you cannot pay the pay rate. You simply pay, you have to calculate the pay rate times the hours worked because it's hourly. And volunteer, you just pay nothing. So the pay method, the implementation for the pay method are all different. That's why as a staff member, there is no way you can define that. That's why you declare it to be abstract and leave the detailed implementation to each child class. Okay, any questions, everybody? Do you all understand this?
So that was kind of like the importance level for the last project. There was different ways of implementing it, so you had to,
Yes, exactly,
Okay.
exactly. If you look at it, yes, because we discussed the inheritance in chapter 9, right? So this is not as difficult to understand. Okay, very good. That is that. Let's go to staff. And remember, so now you should understand this much better, right? Staff member, a staff list is a staff member array, and then you create an executive, employee, hourly, and volunteer. Okay, and now let's look at this statement. Staff list sub-0 dot award bonus. Why do we have to cast staff list sub-0 to executive? Why? So both to combine both of your answers, that's correct. Staff list sub-0, its reference type is staff list, staff member, right? Staff member. Oops. Its reference type is staff member, right? That's the reference type. And its object, the object it points to is executive. So remember, when you compile, where does it look for the method? It looks for the method in the reference type class. So the reference type is staff member, and staff member does not have the award bonus class method. That's why you have to cast this specifically, explicitly back to an executive, because it is an executive. So you cast it to an executive and call the award bonus. This way, at compile time, the system will know specifically to go to executive to find the award bonus method. Okay, and this is exactly the same mechanism, the same rationale, right? Staff list sub-3 is hourly, and hourly is the class that has add hours. So you need to cast it back to hourly. Any questions about this as to why we need to cast it back to executive or hourly? Any questions? To summarize, it's because staff member does not have the award bonus method in it, right? And so you need to specifically tell the system, do not go to staff member to look for that method. Go to executive to look for that method. That's what it is saying. Okay, let's look at this payday. Public void payday. Okay, this is a method in staff. So, okay, so this is obviously a for loop, right? Staff list of length gives you 6, and you print out a staff list sub count. So when you do this, which method is being called? Okay, that's absolutely correct. It's calling the toString method of staff member. And remember, at compile time, it looks for the toString method in staff member, right? At runtime, it will actually use the specific version of the toString method of each individual object. So at compile time, it just looks for the toString method in staff member. At runtime, it will go to executive the first time, and then employee, and then hourly, and then volunteer. It will execute those toString methods. Okay, so that's this statement. And here, amount is equal to staff list subcount dot pay. So this actually is polymorphic also, if you think about it, right? This is also polymorphic. That's the nature of OO, design and programming. It's everything is polymorphic. Okay, this one, staff list sub count dot pay. So this is when it compiles, where does it look for the pay method at compile time? Where?
Be staff member.
Yes, staff member, right? At compile time, it looks for the pay method in staff member because staff list, each staff list element is staff member. That's the type. So it looks for that in staff member. At runtime, it will go to each individual class once again to actually execute the body of that method. So the first time when this is 0, it will go to executive. When it's 1, it goes to employee. When it's 2, goes to employee, etc. So this is definitely the most obvious and good polymorphic reference, right? You look at it, you don't need to go into each individual class. You're using that mechanism so that you can just use one statement and you are calling different pay method. Think about it, that's very magical. It's really so graceful if you look at it, right? It's very graceful because it doesn't have all lines of code to call the different pay method. It's just one line. But because of the polymorphism principle behind it, you use one succinct line and you are calling 6 different methods. How beautiful is that? You think about it, right? Okay, so if amount is 0, this is easy to understand. The main thing is you need to understand this part. These are the polymorphic reference, right? That's the staff. So when you go to firm, if you remember, staff is that class we just discussed. So create the new staff and call the payday method. And that is the staff, right? That is the staff. So you instantiate that, call this constructor. So now you have 6 here. And then you just go to payday, call payday, and everybody gets paid happily. So if you need to add a new staff member, you just need to come to this one class to make the change, right? Okay, let's run it again, and so that you can see. That's the firm class, the firm program. Okay, so all this you can see is the pay is calculated differently. So beautiful if you think about it, right? It's very, very graceful, really. Okay, any questions, everybody? Interface, as you remember, is what? Interface is a collection of abstract methods. And by default, it's a collection of abstract methods. So you do not need to have the abstract keyword here, right? You do not need to have that here. Okay, an interface name used can be, okay, so first interfaces can be used to set up polymorphic references as well. Suppose we have an interface called speaker, okay, and with 2 abstract methods. An interface name can be used as a type of an object reference variable. So you can use it as a reference variable. You can do this, declaring a speaker reference variable. However, you cannot do this, right? We learned this in chapter 8. And you have, don't remember if you have a question on this. However, you cannot do this. That means you cannot instantiate an interface object. It doesn't exist. So this is not okay, but you can declare a variable from an interface, okay? This is good. The current reference can be used to point to any object of any class that implements the speaker interface. So it cannot be instantiated, but if you have a class that implements this interface, then this variable can point to an object of that type. Okay, so the version of speak invoked by the following line depends on the type of object that current is referencing. So once again, you look at this, current is a speaker reference variable, and dot speak, okay? At compile time, the system will go to the speaker reference, speaker interface and see if it has the speak method. So this will compile. At runtime, it depends on what this points to. It will execute the method in that specific class. It's the same as inheritance. Okay. So let's look at this. Now suppose two classes, philosophy and philosopher and dog, both implement the speaker interface. Okay, both implement the speaker interface, provide distinct versions of the speak. A philosopher, of course, speaks differently from a dog, right? So you have to have two different versions. That's why you have them separate as two classes. Okay, the first call to speak invokes one version. Okay, let's look at this. Speaker guest. Okay, this is the reference variable. The reference type is speaker. I want to make sure I'm recording. And new philosopher. This is okay because philosopher implements, it already said, implements speaker, right? So this is an actual class. So now we have a speaker reference variable referencing a philosopher object. So this is good. And then guest.speak. Okay. So I already have this here, invokes the version in philosopher. Okay, once again, at compile time, it will look for the speak method in speaker, right? In the reference type. At runtime, it will look for the body of philosopher because guest points to a philosopher object. Okay. And then you are having the speaker reference to point to, it's like you have this speaker reference. Where? No. Okay, you have guest, right? This is your reference variable. Now it points to philosopher here. And at this time, right, it points to philosopher. And when you call speak, it will go to philosopher to find the speak method. And then here you're saying, no, I'm not a philosopher anymore. I'm a dog. So it will point to a dog. And this is broken because each time it can only point to one type. So this is broken. And this philosopher object is floating. And then it will be garbage collected by the garbage collection, of course. So philosopher goes to garbage. And dog takes over. So now guest is pointing to the dog object. And then when it says speak, it will bark, right? It will call the dog method of the speak method of the dog version. So that's what this is. Any questions?
So you can only have like one interface reference?
Say it again, Asa. You can only have one
So you
interface
can
reference?
You can only have like one interface, like a reference, like on your objects?
No, you can declare other speaker references. You can say speaker guest 2. You can do that. Not sure if that was your question, but here it's just reusing. Okay, I think that might be your question. It's just reusing the guest reference. So it's doing this.
Oh, okay. Oh, okay.
Okay, can you simply say speaker dog equals to new dog? Definitely, right? But now you have two reference variables. One is guest, one is dog. But here it's just reusing this reference variable. Suppose you are done with philosopher, right? So you just reuse this reference variable to point to a dog, which you can because of polymorphism.
Okay, yeah, that answered it. My bad. Yeah.
Okay. Any other questions, everybody? Okay. As with class reference types, the superclass, child class, the compiler will restrict invocation to methods in the interface to the reference type. Everybody remember the reference type. The compiler will restrict invocation to methods in the reference type. Okay, so that's again, I said this so many times. At compile time, it looks for the method in the reference type. So at compile time, this will look for the method in speaker. Okay, that's why it will not compile, because speaker doesn't have the method pontificate. Okay, that is a method that a dog cannot pontificate. It can. It does that all the time. We just don't know what they are pontificating, right? But a philosopher definitely. The philosopher always pontificate. So here at compile time, it looks for that method in speaker, and at runtime, it will look for that method. It will execute the method in that referenced object, which is philosopher. So that's why at compile time, this will not compile, because speaker does not have that method. Okay, so as for example, even if philosopher also had a method called pontificate, the following would still cause a compiler error, because it looks for that method in the reference type. Okay, so if you do this, it will compile. You are saying, okay, special is a speaker reference type. However, I'm making it temporarily into a philosopher reference type. And then I call this method. Now it can compile. This is just like what we did the other day with the Christmas tree, right? It's the same concept. Any questions about this, everybody? Okay, let me ask you a question I just explained. Why do we need to cast special to a philosopher to call this pontificate method? Why? That's correct. So that at compile time, it will be able to find that method, right, in the philosopher class. Absolutely correct. Very good. Okay, so that you make it compile. Otherwise, it doesn't translate it into object code, and there is no way you can execute it. Okay, let's do these. You know, how about do not look at that first yet, and let's just think, you know what, I will, I cannot hide that, right? Okay, let's not hide it. Let's look at it and see if you understand it, right? Don't look at these answers and just look at these. So this is valid because you will have questions on these. So you need to think yourself first. Okay, so this is good. Oh, is this good, everybody? The first one, is it okay?
No.
Why not?
Because it's an it's an interface or an abstract. So you can't create an object of speaker, a speaker object.
Yes, because a speaker, I took it away, the answers away. So you can really think, you can think for yourself first. Okay, so this is not okay because you cannot instantiate a speaker object. Assume the speaker interface and the philosopher and dog classes as described, right? Philosopher and dog implement the speaker interface. Okay, what about this one? Is this one okay, everybody?
Yes.
Yes, because dog implements speaker, so it's good. This is definitely okay. You are declaring two reference variables of the speaker interface. Is this statement valid?
Yes, that one is valid because a dog implements a speaker as well.
Yes, a dog is a speaker, so this is good. And dog is an actual class. It's not an interface. So this is good. What about this one? Second one. Is it correct?
Yes, it's the same thing as the first.
Yes, it's the same thing as the first one. You're creating a philosopher object referenced by second, which is speaker reference variable. Okay, is this okay?
No,
No?
because it can't reference speak back to the speaker.
I think, does speaker have, yeah, speaker has speak in it, doesn't it?
Yeah, yeah.
But if we're going back.
Once again, this is the
Oh, okay. We're
right?
going back. Okay.
Okay, so suppose it has those two methods. So is this statement valid? Everybody, once again.
Yes.
Yes, it's valid. Yes, it's valid. What about this one? First is equal to second. Is that valid?
Yes.
Yes. Why?
It's like originally first equals dog and second equals philosopher, but now it's changing the definition of it to equal the other.
Yes. So this is valid because remember they are both speaker reference variables, right? So you can assign one reference variable to another. So now first it's pointing to what? First, it's pointing philosopher, right? First, it's pointing to whatever second is pointing to. So first, it's pointing to philosopher. This is called aliases, if you remember, right? They are aliases of each other. They are the same reference variable. Okay, now let's look at this one. Is this one okay? Yes, we already established that, right? Right there. Is this one okay? Yes, definitely. Is this one okay? Everybody? The third statement.
Yes.
Yes, why?
The pontificate method is in philosopher.
Yes, yes, pontificate method is in philosopher, and second is a philosopher reference variable, so it compiles. What about this one? Is this one okay?
Yes, because because philosopher, which second is pointing to, is a speaker, which is what first is pointing to.
Yes, yes, this is okay because you always ask yourself once again, is this one this, right? Is a philosopher speaker? Yes, then it's okay, right? Because this is a speaker reference variable and this is a philosopher reference variable. So is a philosopher a speaker? Yes,
Yeah.
So it's valid. Questions? Okay, this one definitely it's okay. This one definitely it's okay. And already established it's okay, right? Second, so a speaker reference variable is pointing to a philosopher reference variable, that's fine. Second, pontificate, that's okay. First, pontificate, is this okay?
Oh, yes.
Yes?
Right, because it's pointing to philosopher or no?
So that's my
First
question.
is pointing to speaker, and speaker doesn't have pontificate.
Okay, so you are saying this will not compile?
It won't compile.
It won't compile because once again, first is the reference variable, its reference type is speaker. So no matter what, this is just pointing to it, but its basic type is still whatever the reference type is. So when you do first pontificate, you are saying, oops, you are saying the speaker, the system will look for the pontificate method in the speaker interface. So this will not compile. Okay,
So
everybody?
you have to cast that.
Yes, you have to cast it. Exactly, you have to cast it because now it is pointing actually to a philosopher, right? So you can cast it. Okay. Any other questions? This is why do you need to know this? When you write your program, if it doesn't compile, think about what we said here, right? And then you will know, oh, I need to cast it. Oh, it's because of that. Okay, this is all technical, really syntactic problems you need to understand, and logical. Any questions, everybody? No questions? Okay, let's continue. So we finished late binding, polymorphism via inheritance, and polymorphism via interfaces. And these are really the essence, okay, I would say the essence of OOD, object-oriented design, and OOP, which is object-oriented programming. These are the essence. If you look at all the programming, the more complicated programs, they involve inheritance and interfaces, okay, and late binding. So let's go to the next part. If you don't have any questions, once again, do you have any questions, everybody? Okay, I will let you read this yourself. It's easy to understand. I think my speaker may be too loud. Oh, it's 100%. I may have ruined your ears. That's too much. I don't know how the in order, usually from low to high. Okay. And so let's look at this algorithm. This is the detailed, this is the algorithm, okay? So it's called the selection sort and insertion sort are two of the most, it's the easiest algorithms to understand. So that's why we are talking about them in this class. Okay, they are the easiest to understand. Selection sort means you select the smallest value and put it in its final place. Okay, so select a value and select the smallest, select a value and put it in its final place in the list. Repeat for all other values. So in more detail, you'll find the smallest value in the list. Switch it with the value in the first position. Find the next smallest value in the list. Switch it with the value in the second position and repeat all this until everybody is sorted. Okay, so why is it called selection sort? It's because you are selecting. What are you selecting? Usually, you are not selecting the largest unless you want to sort them that way, right? You are selecting the smallest and put it in its final place, and then select the smallest, next smallest, and put it in its final place. That's why it's called selection sort. Okay, let's look at this example. So suppose this is the list, okay? Suppose this is the list. We go through the list. Suppose you say, okay, I will say 3 is the smallest. Okay, when you think about actually when you program, you will say, okay, let's make 3 the smallest, the very first one. Compare 3 with 9. 3 remains to be the smallest. Compare 3 with 6. 3 remains to be the smallest. Compare 3 with 1. Now your minimum number is 1, right? So your main is 1. And compare 1 with 2. And 1 is still the main. So after you scan through the whole list, you find the smallest variable, the value, and you switch this with the first position. So after the first round, your 1 comes here and your 3 comes here, right? Okay, that's the switch. So first you find it and then you switch to put it in the final position. 1 will not go anywhere. It will stay here forever. And so now we look at this list. Suppose we say 9 is the smallest, and we compare it with the next element. Now smallest is 6, and we compare 6 with 3. Now the smallest is 3. We compare 3 with 2, and now the smallest becomes 2, right? So we switch them. Once again, we switch them. 2 comes here, and 9 comes to 2's place right here. Okay, so now we have these two numbers in their final place. And now we look at these three elements, okay? Suppose make 6 the smallest number and compare it with the next element. Now you reassign 3 to the smallest number and compare 3 with 9, and smallest number remains 3. So you switch them. And now these 3 are sorted and in their final place. Now you have these 2 left. Assume 6 is the smallest. You compare 6 with 9, and 6 remains the smallest. So you switch 6 with itself, switch this element with itself, okay? Now you have that. And then this is the last element, which means you do not need to do anything because you are selecting the smallest elements in the list, and the leftover is the largest. So you don't need to do anything. With the 5 elements of this array, you just do the selection 4 times, right? If you have 6 elements, you will do it 5 times. If you have 10 elements, you will do it 9 times, because the last element is the leftover. It's largest by default. Any questions about this algorithm? That's the selection algorithm. Everybody, any questions? And I give you detailed explanation of this. And you can look at that, okay? So this one actually is not just the algorithm. I'm really using the code to show you how it works, okay? So swapping. The processing of the selection sort algorithm includes the swapping of 2 values. When you swap, you cannot do this, something like this. Is this swapping? No, because when you do this, which value did we lose, everybody? When you do this, what value did we lose?
The first.
The first. We lost the value in first, because first, you are doing first is equal to second. So now first is pointing to the value in second. And second then points back to first, which points to second. So second is equal to second, basically. So you are losing the value in first. That's why you do it this way with 3 statements, okay? Place first, save it first, place it in a temporary variable. So you have it there. In this case, you see first is nowhere to be seen, right? So we put it in a temporary variable and then place the value in second in first, and then place the value in temp, which is the value for first, into second. So this is how you swap values, not like this. This way you are losing what is in first, okay? Any questions, everybody? Okay. So here I am explaining if we are sorting a list of int values, okay, we can define a method that accepts an int array, right? The method can only be used to sort a list of int values. Then what if you want to sort a list of strings? What if you want to sort a list of characters? So if we want to sort a list of char or double or string or any other objects or primitive data types, we have to redefine methods that accept those types. You have to overload each method with a different signature, right? To solve that problem, that's where polymorphism comes in, okay? So to solve that problem, a solution is to implement the algorithm with an implementation such that it can sort any set of objects, any, okay, not just int, not just char, but any. Therefore, we will dictate that the searching, we are not searching, right? But that's okay, it's the same. the searching or sorting pool must implement the comparable interface. This technique allows each class to decide for itself what it means for one object to be less than, equal to, or greater than another. So if your method says, I'm not accepting only an int, I'm not only accepting a char, I'm not only accepting a string, I'm accepting anything that's comparable, I will be able to sort you. So you do not have to redefine the method with many different versions. You use this one version of sort, then if your object implements comparable, I can sort you. That's what this is saying. This way, as long as the objects implement the comparable interface, the sort method can be used. Okay. Do you kind of understand this, this page, everyone? If you have a method, currently, you know, if we have a method, we accept something as a parameter, that parameter must have a data type, right? So you can define a method called selection sort that accepts an int type. Then what if you want to sort a list of characters? You have to define a new method, overload that method, and say accept char. What if you want to sort doubles? What if you want to sort student? What if you want to sort desks, computers, anything, right? Staff members, employees. How do you sort them? Do you need to provide a overloaded version for each type? That would be infeasible. It's impossible to do. So a solution is, okay, let's just define this method, and we will dictate that the method only accepts comparable objects. Okay, so that means if you want to use me to sort your stuff must be able to be compared with one another. If I cannot sort you. So if you want to be sorted, you have to implement the comparable interface. That's what this is saying, okay? So recall that a class that implements the comparable interface defines a compare to method. So comparable is an interface. It has only one method that's compare to, okay? And to determine the relative order of its objects. And remember, compare to returns an int. It returns negative if this object is less than the other one. It returns positive if the current object is greater than the compared one. It returns 0 if they are equal. So that's the compare to method. So here is the thing. You have the equals method, which only returns a Boolean value, true or false. They are equal or not. We implemented that method last class, right? Now, this compare to method will compare if one comes after the other or one comes before the other. So because of this compare to method, it tells you which one comes first or which one comes after. You can put things in order based on this. That's why we are talking about this. Okay, let's look at an example that sorts an array of contact objects. Okay. So recall that comparable interface has only one method, right? Compare to. And I discussed this already. I will let you have a look. We discussed it already, actually. Okay, do you understand this, everybody?
Yes.
Yes, okay. Let me ask you this question. If I change this integer to int, will this be okay? That's something I did not discuss. That will not be okay. Why? Because this is what? Int is what type?
Is primitive.
Yes, it's primitive. It's called primitive. That means it's built into the language. It's not a class, okay? It's not an object. So that's why we use integer. These are methods, right? Method can only be used on objects, okay? So you understand this. Now let's look at this example. I don't think I have it here. Phone list, I don't have it. That's fine. Let's look at this. Okay, so contact, this is the main method. We, this friends is of contact type, right? 8 contacts, and you just instantiate them. Obviously, contact has first name, last name, and phone number. And then we use the sorting, the selection sort method, okay? We sort this. And then when we print it out, that's the result. If you look at the result, everything is sorted, right? Barnes originally is which one? It's the second one. Now it becomes the first one. So obviously we are sorting them based on last name. And when they have the same last name, we are sorting them based on first name. When their last names are the same, we sort them based on first name, right? And that's usually how you sort names, strings, people based on first name and last name. Unless, you can sort people by GPA. Of course you can do that. Then you will implement the compare to method differently, right? Okay, so see how easy this is. This is sorting is the class name and selection sort is the method name. And what does this tell you, everybody? What is this method? What does it tell you? It's a what method? Starting with S.
A static method.
Followed by T.
Yeah, static.
Followed by A. Static method, right? It's a static method because this sorting class, really, you do not have any, here is the sorting class, okay. You really do not have any instance variables. It's just, oh, I have it here, right? Okay, context. So let me close that one. Okay, so if you look at this, this is context. This is the contact class. It implements comparable, and this part you don't really understand it yet. We will do this in class 3, actually. You don't quite understand it. But this is the private instance variables, and this is the constructor, toString, right? And equals. We discussed equals. We implemented equals method last class. So equals, you just need to compare the first name and last name. Compare the last name and first name and see if they are the same, right? Why do we need to cast other back to contact, everybody? Why? Why do we need to cast it? Yes, because what we passed from the parameter is an object. An object class doesn't have the get last name method. Which class does? The contact class. And this is supposed to be a contact object because you cannot compare apples with oranges. You have to compare the same type. So, but because equals is a method in the object class, so its parameters type is object. You remember there are 3 methods, clone, equals, and toString, right? So that's why it accepts object. But then you need to cast it into a contact class object to call the get last name method because that's where it is. Get last name, get first name. Okay, that's why we do that. So you see the equals method, we did this last time, and we did with words, with dictionary. And that's an implementation that's comparing the number of pages. You are comparing really the instance variables. In this case, we are saying phone number doesn't matter. As long as your first name and last name are the same, you're equal, even if you have a different number. Okay, so that you decide what equality means. You have your own definition. And in this case, it's only first name and last name. And then let's look at compare to. I think after this, we will stop. Compare to, okay, give me a contact, right? And then if last name dot equals, remember this one is always talking about the current object, right? The current object, last name. That's the current object. Dot equals other dot get last name. And here compare to is accepting a contact. The reason this is okay is because compare to is comparable. It's not object. So, and here we are saying I'm only comparing with a comparable contact. And that's something we will discuss in class 3, of course. So, so here, because it's a contact, and we can directly use the get last name method. Okay, if the last names are equal, then we will compare the first name, and we do first name dot compare to other dot get first name. Why can we call the compare to method directly here? Because first name is a string object. First name is a string, and string has already implemented the compare to method. So string implements comparable. It's already done by the Java developer. That's why you can directly call this method, right? So else you simply, if last names are not equal, you simply compare last names. If last names are equal, then you compare the first name. If they are not equal, you compare last name. And last name get first name. That is what? Once again, it's the string, right? String implements compare to already. And so you just use it to do the comparison. Any questions about this, everybody? Do you, I did not record what I said. Are you still here, everybody?
Yes.
What are we comparing a book
Yes.
with? Think about it. We're comparing a book with what? Can we compare an apple with oranges? No. When we compare an apple, what do we compare an apple with?
Another apple.
Okay. When we compare a book, what are we comparing it with?
Book.
A book,
Other books.
right? Okay. So now we need to implement. What is it? Okay. So now let's. I will do this very quickly. Okay. Public int returns an int, right? Compare, right? And what are we comparing it with? Book. And so this is really, really simple. You are comparing the number of pages because that is the only instance variable. So you will say if, right? Pages equal to b dot get pages. It has that method, get pages, right? Get pages. Okay, if they are equal, what do we do? Return 0. Okay. If pages is less than what? B dot get pages, then we return -1 in this case, right? Okay, that is Python. Okay, else, that means it's less. So we return a +1. Okay, that is your compare to method. Does that make sense, everybody? Do you understand it?
Yes.
Compare to, it's not difficult. It's very easy. You just make sure you're comparing with yourself, right? Okay, you implement comparable, compare yourself with yourself, the same type. And then you simply make sure you return an int, depending on how you define it, really. And then if you go to dictionary, you will call the super method, just make sure they're whatever it returns, and then make sure you add this part to it, definition. So you not only compare the page numbers, you also need to compare the number of definitions, right? We don't have time to do that, but just look at this. This is a good example. This is a very simple implementation. It's really based on what your instance variables are and what you want to compare. If you have other instance variables here, title, you need to compare title also. If the titles are not the same, then definitely they are not the same. If the titles are the same, then you need to compare the number of pages, right? So that's how you implement this, okay? We will stop here. This we need to really talk about the search, the selection sort also. Okay, I am going to stop recording.